if I do my notes in here and copy them over?
You don't have to do them on here. Yeah, that's fine. This is more organized for most people. Okay, so here we go. The first problem on our new notes, this is page 8, is what kind of an equation? What do we call this? Well, it's a trinomial for sure. It has 3 terms. What degree is it? What type of equation is it? It is definitely a trinomial for sure. But what kind of equation do we call this? It is not a linear equation. It is a, well, it is definitely nonlinear. It is a quadratic. X squared, I didn't hear you. You gotta talk loud, I'm old. X squared is a quadratic equation. So, what are our options when it comes to solving a quadratic equation? This is review. We have already discussed this. What are our options? Mary Kate?
Quadratic formula.
We could use the quadratic formula. We could graph it on our calculator. We're doing non-calculator methods right now. So we could try to factor it, and we could complete the square. And actually, this one would not be bad to complete the square because we've got to take half of this. As long as that's an even number, that's easy. I really don't like this fraction hanging around out here though. I mean, I can do it with the fraction, but it might be easier to not have the fraction. So what would I do if I didn't want to deal with the fraction? Because remember, quadratic formula is easy. But if you use this exact equation, you're going to have a fraction under that radical. When you do b squared minus 4ac, there's going to be a fraction under there. So what might we want to do, Mary Kate? Multiply everything by 3. So if I multiply everything by 3, everything in the whole equation, including the 0, but that just stays 0, I would no longer have a fraction. Now, I would no longer want to complete the square because I can't do it when there's a number out here, but I certainly could do the quadratic formula, right? So x equals negative b plus or minus. By the way, yesterday was the last time that you're not going to have the quadratic formula memorized. So you're big kids, it needs to be memorized. So negative b plus or minus the square root of b squared minus 4ac. This is total review. We did this yesterday on your test, this kind of thing. This is still causing some of us problems. A negative and a negative, what operation am I going to end up doing under here? I'm going to add. This is going to be an addition, not a subtraction problem, because you have a double negative. So I have 12 plus or minus, it's going to be 144 plus 12, 4 times 3 times 1, which is going to give me 156 under there. Now, can I cancel the 6 and the 12? No. Don't ever cancel unless you can do all 3 spots, right? Now, what can I do though? Or what do I need to at least try to do? I need to try to break this down. Okay? So 156 breaks down. I always just start with 2, but you don't have to. So I think it breaks down into 2, 2, 3, and 13 if I did that right. So what does that mean in terms of simplification? A 2 can come out because you got 2 of them. So a 2 can come out. And the 39 has to stay under because even though the 39 breaks down, it doesn't break down into 2 of anything. Now can we cancel? Yes, because now we can take a 2 out of this, and this, and this. And those are the 3 spots that you have to be able to cancel from if you're going to cancel. So 6 plus or minus root 39 over 3 is our answer. Okay? All right, next. So we got another one, it looks like. It's a little bit bigger. What do you suggest we do with the next one? Yeah, looks like there's a little foiling to do on that one side. So we'll foil that out. So we'll leave this side alone for the time being. And then this side I'm going to foil, so that's going to be x squared minus 2x plus x minus 2. And then don't forget, there's that 5x on the end. Okay. Now what? I foiled.
Do we have to combine all this?
Okay, we can clean up all this mess over here. So again, I'll leave this side alone for now. And all of these can be added up. So x squared. Okay, now wait, there's a lot of them. So that would be, did you get 4x?
Yes. Minus 2.
Okay. Eli, your mask has to be over your mouth and nose. Thank you. What now? Well, I don't think I want to factor yet. Factoring is not a bad idea, but I need to do something else first. Ella?
Can you start like subtracting the 4x's and the x squared? Can you bring that over to?
Yes, so we want to get the equation set equal to 0. Anytime we have a quadratic equation, an x squared equation, we want to get it set equal to 0. Then we can start doing our things. We can quadratic formula, factor, complete the square, but we need to get it set equal to 0. So we're going to subtract x squared. That's going to give me 2x squared. I'm going to subtract 4x. That gives me negative 8x. I'm going to add 2. That gives me 4. So did I do my arithmetic correctly?
Yes.
Now the equation is ready to do something to. Actually, could I divide everything by 2? I do not have to do this. I don't have to divide everything by 2, but since everything is divisible by 2, I might as well, because that gives me smaller numbers. Okay? Now, what do you want to do at this point? Well, you can try to factor. I'm not sure this one does. Always you can try that, but it doesn't always work. I don't think I can make that one work, can I? So what am I going to do? I can use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this one is going to be a subtraction under there. It's going to be 16 minus 8. Because there's only one negative, so it's going to be subtraction. So I have 4 plus or minus the square root of 8. Can I cancel at this point? No, no, no. You have to cancel all 3 spots. And there's nothing here to cancel. So what do I need to do? Break down 8. 8 you probably have memorized because you use it all the time. 8 is 2 root 2. But if you don't have it memorized, you're gonna break it down.
Can you then do the divide by 2?
So there's 2 2's. So that's why it's 2 root 2. And now can I cancel?
Yeah.
Yeah. Now I can. So 1, 1, 2. So my answer ends up being 2 plus or minus root 2. Mary Kate?
What? Okay, after you take out the 2, like way back over there.
Here?
Yeah. What is your C? Your C is 2. I forgot that.
Because it was 4, but I divided by 2.
Like, how did 2 disappear on the bottom? On the, like,
Here?
isn't it A times 2, so wouldn't that be 4?
Oh.
On the bottom of the,
Go down here?
yeah, so then the bottom of that would be 2, because you divided it by 2 for the final answer.
I did, right here.
Isn't it 2 times A on the bottom of like the?
It is, but A is 1.
Oh.
Yeah, that's
Where did I get 2?
If you divide by 2, this is your equation to get your A, B, and C. If you left it like this, then your A, B, and C are 2, -8, and 4. And then when you simplify your problem, you're gonna have a bunch of stuff canceling out, and you're still gonna end up with this answer.
Yeah.
But it will look different because you've got, the work will look different because you're using a different A, B, and C. Okay? If you divide by 2, then this is the A, B, and C you have to use. If you don't divide by 2, then you can use those. And it'll work either way. All right. Oh, there's a couple more. Here we go. X minus 4 equals 5. What do you think we ought to do with this one? Okay. All right. So distribute and subtract the 5. Sounds like a good plan. So x squared minus 4x minus 5.
Yeah. And then it factors.
That one factors. Now, what if you don't see that it factors? You could use the quadratic formula and do exactly what we just did. X minus 5, x plus 1. Now, I'm going to talk about that for a minute. Factoring is an essential skill. It is something you're going to have to do in some problems. You do not have to do it in this problem, but you will need to know how to factor in some problems. When you factor, take a minute and FOIL it back out to make sure that it gives you what you wanted. On the test, several of you tried to factor things, and that was fine, totally fine, but you factored wrong. And when you factor wrong, you get the wrong answer, obviously. And there's no reason to ever factor wrong, because you can always check. And if it doesn't check, then go back and try a different, factoring combination. That is factored correctly, so it's ready to go. So that means, I think some of you have forgotten, that means you set both of these equal to 0. Most of us at this age do it in our heads, but if you have to write it down so that you can see x equals 5 and x equals -1. What would happen if we did the quadratic formula? We would get exactly the same answers, right? The work would look different, but we'd get exactly the same answers. Those are the answers to the problem. All right, what about this one? So, yeah, we could, subtract the x squared. That's fine. I'd rather add the 3x squared because I like to have positives on my squareds. It's just a quirky thing I
But
have.
would it be fine if I did it the other way?
Oh, sure.
In the end?
Sure.
Even though you get different numbers?
You won't get different numbers. You'll You'll get
Well, yeah.
negative 15 equals negative 4x squared.
Yeah.
Yeah. So x squared equals 15 fourths.
And then you have to add
So x equals plus or minus the square root of 15 over 2. Remember, when you have the square root of a fraction, you do the square root of the top and the square root of the bottom. What?
Wait, so you just, after you do that, you just divided the 4 over?
Uh-huh. Yep, and took the square root. Now, could I have set this thing equal to 0 and done the quadratic formula? Yes, but if I did, A would be 4. What would B be? 0. And C would be negative 15. So if you did the quadratic formula with that, that would be fine. Just pay attention, B is 0. What?
Why is it 15 over 2 on there?
Because it was 15 over 4. And the square root of 15 is just the square root of 15. What's the square root of 4? When you take the square, it's the square root of 15 over 2. Because when you do the square root of a fraction, you do the square root of the top over the square root of the bottom. And the square root of 4 is just 2. So if that confuses you, you can do the quadratic formula. Just make sure you're putting in 0 for your B value. All right, is that it on that page? It is. That's it for the review stuff. So now we're starting the actual chapter. All right. So, question number 1. Let's see if you remember how you tell if things are functions or not. Vertical line test. And how does the vertical line test work? I mean, how do I operate? I think we all remember something called the vertical line test, but how does that work? We just draw, or we don't even need to physically do it, but we visualize vertical lines drawn down through our picture. And what's the rule? Caroline?
Isn't it if it only, so like, if it's like a circle, it crosses it twice?
So,
that's like not a
yes.
function?
So if each line hits the curve, in no more than one place, it's a function. So you just either draw them in or think about them. But if you draw a bunch of vertical lines and they only hit your picture one time, then it's a function. So this would be a yes, right? The question is, which are functions? That's a yes. What about B? This is B right here.
No.
It's a no, because when I draw that line down, that vertical line, it hits here and here. And remember, they can hit no more than once. So that's a no. What about C? This is a squiggler. That's a yes. Hits only one time. So B was a no, but C is a yes. What about D is a circle? No. D would be a no, because when you draw your vertical lines down through, it doesn't pass the vertical line test. What about E?
Is it a triangle?
Good question. No, I think it's just an upside down V. So if it's just,
So then it's a function.
if this is the curve, just the red, if the red is the curve, then it is a function. If this was the curve, then it would not be a function, right? But I think it's just the triangle part, or the V part. And then what about F? No. It is a no. So, is everybody reasonably confident with identifying whether things are functions, whether pictures are functions or not?
Yes.
All right. So then the next thing we have to do is talk a little bit about domain. Anybody know what the word domain refers to?
The bottom of the fraction?
The what?
Is it like the bottom of the fraction?
The bottom of a fraction is called the denominator, but Clara, actually, the bottom of the fraction has huge implications in domain. So we're going to look at the bottom of the fraction to determine the domain. Anybody else have a guess or a thought on what domain is? So domain is associated with the x's, that's right. So domain is the set of x values in a function. So in other words, if I came over here and looked at this first picture that we looked at, would you agree that each of these are points, right? I mean, all those blue things there are points. They all have x coordinates. So if this is the point 4, 3, and this is the point 1, 2, 0, 0, and negative 1, 2, and so on. The domain would be the 4, the 1, the 0, the negative 1, the x coordinates. Those are the domain. And the rule for functions is they can't repeat. So the domain is hugely important when you're dealing with functions. There are two big things for you to consider, and I'm just going to call them two big things for you to keep in mind when we do domain. If you keep these two things in mind all the time when we do domain, you will not have any problems with this. First, the denominator, so there's that denominator, Clara, cannot be 0. So if you have a fraction, whatever you put in the denominator cannot be 0. We're going to do some examples. The second thing is, whatever is under the radical must be greater than or equal to 0. So in other words, if you have a square root in your problem, whatever x's are underneath it have to be positive. Because what happens when you put something negative under a radical? You get an I. And we don't want to be imaginary. We want to be real here. So whatever's under our radical is going to be positive, and whatever's in our denominator is not going to be 0. All right, let's do some examples and see if we can figure this out. Don't overcomplicate it. It's really, really important, but it really is that easy. You think about those two things. So my first example is this. And your job is to find the domain. So here's what I want you to ask yourself. Is there a denominator in that problem? No. So I don't need to worry about this. Is there a radical in that problem?
Yeah.
There's a radical in that problem? Do you see a square root symbol in that problem? No. If there is no fraction and there is no radical, then there is no issue with this domain. The domain is all real numbers. There's no problem, no limitations. X can be anything. This is the symbol for all real numbers. If you want to write all real numbers, that's fine. You can use the symbol, or you can just write all real numbers. Why is the domain all real numbers? Because there isn't a problem. These are the problems. There's no fraction, there's no radical. If you don't have a fraction and you don't have a radical, then you don't have an issue. And the domain is everything. But now we look at the next one, and the first thing we notice in the next one, and by the way, this letter has nothing to do with it. Functions can be named whatever you want. Remember our projectile motion function was S of t? Doesn't matter. G of x, f of x, s of t, that's irrelevant. Don't get hung up about that. So this particular function named g looks like this. Now, look at your big things. Does that problem have a denominator? No, so I don't need to worry about that. But does it have a radical? Yes. So that means that whatever is under the radical must be greater than or equal to 0. So your domain is x plus 5 greater than or equal to 0. Whatever is under the radical has to be greater than or equal to 0. So what is the domain? Solve that. X is greater than or equal to negative 5? What? No. That's the answer. This is the domain. This is the domain right here. That's the answer. So when you're figuring out the domain, there are two considerations that you have. One involves a denominator, which we don't have in this problem, and the other involves a radical. If you have a radical, then to find your domain, whatever is under the radical, set it greater than or equal to 0 and solve. And that becomes your domain. So if we were going to graph this thing or something, these are the only x's that we would be allowed to use. So that's the domain. It's that easy. So if you can remember these things right here, it's easy. All right, let's look at C. So C, your job, you're finding the domain. So these are the two big things you think about. They're the only two things you think about. So h of x equals 1 over x plus 5. Okay, so what are our two things again? Do we have a fraction? Do we have a radical? Okay, I don't have a radical, but I do have a fraction. So what's the rule for a fraction? The denominator cannot be 0, which means x cannot be negative 5. So what you're telling me is my domain is anything in the world except negative 5. Okay? Everything except negative 5. All right, what about D? D is, this is the answer. That's your domain.
Is that the little thing we're doing equal to faster?
That it is not equal to. So what you're saying to me is x cannot be negative 5. That's what this means. So, Clara, if I said to you x cannot be negative 5, what is the implication of that? X can be anything except negative 5, right? That's your domain.
How'd you get a negative?
Okay, how about D? Again, think about your two things. Does this problem have a radical? No, so I don't need to worry about that. Does this problem have a denominator? Yes. And the rule is the denominator cannot be 0. So 4x minus 1 cannot be, is not equal to 0.
So 4x is not equal to 1.
So I'll add 1 and divide by 4. So your domain is x cannot be 1/4. X can be anything in the world except 1/4. Now we're working toward graphing these things. So being able to find the domain is an important first step in graphing.
We're not worried about the combo.
No,
Like it's only.
no. Remember the big things I had written over
Yeah.
here? That's what you worry about,
Yeah.
okay? The two things that I had written over here, that's what you worry about. Now, when we get to graphing, we'll have to involve the whole problem, but for domain, these are the two things we worry about. E is a tricky problem. Let's see what's tricky about it.
Do you just subtract the numerator?
Huh?
Do you subtract the numerator with your step?
We never, if we're doing domain, we don't do anything with the numerator. If we are doing domain, and that's what this question is, it says find the domain. My beady little eyes look for two things. A radical, don't have one, and a denominator, I have it. So the rule is, whatever is in the denominator cannot be 0. Okay? So I'm going to subtract 1. Anything about this starting to bother you? I said this was a trick question. It is. Anything here starting to bother you?
X squared.
Well, it's not the fact that we have an x squared, it's the fact that x squared is going to equal a negative number. So when I square root it, what's going to happen? I'm going to have an I. Do I want I's? No, actually, quite the opposite. This domain is all real numbers. This means that there is nothing that interferes with the domain. There is no way that will ever be 0. That can't be 0. So you can put anything you want into this problem, and you will never get a 0 on the bottom. And that's the rule. The rule is you can't have a 0 on the bottom. Think about it. Can you square something, multiply it by 3, add 1, and get 0? Can that happen? No. So this domain, you can put anything you want in here. You can put 5 in, negative 18, square root of 19 over 3. It doesn't matter. You can put anything you want in here, and it's going to be okay. So the domain is all real numbers. This would tell you if there was a restriction, but this came out imaginary. So there's no problem. That is all real numbers, even though it has a fraction.
So if we get another problem and we have to square the x and the fraction, it's gonna be all reals.
No, that has nothing to do with it. That's the problem.
Oh, the number.
That's the problem. When you square root a negative, you get imaginary. And we don't want imaginaries. So it's not the fraction that's the problem. It's not the squared that's the problem. It's that. All right, F. How about this one? Now, first of all, let's clarify. We're finding domain. No solution will never be an answer. If you have nothing in your domain, then you don't have a function. So that will never be an answer. So stop saying that, okay? What do we look at to find the domain? Two things. Do I have a radical in my problem? Nope, don't worry about it then. Do I have a fraction in my problem? Yes. And the rule for the fraction is whatever is in the denominator cannot equal 0. So that means when I divide by 3, I still have 0, right? So what does that mean? My domain is everything except 0. It's everything except 0. When you write this down, that means you can be 1, you can be 5, you can be 12, but you can't be 0. All right, what about G?
The all real numbers.
Nope.
X squared minus 9 could not equal
how we start.
And then x squared is 9.
So
Cannot
x
equal
squared cannot be 9.
9. And then you can square both, or not.
And when you square root,
You get x cannot equal to
x can actually plus or minus. It's that same old plus or minus thing. Now, some of you may, if that makes sense to you, that's perfect. This is the domain. X can't be 3, x can't be negative 3. Some of you may have, when you saw this, thought about factoring it. Doesn't that factor?
Yeah.
And then that means x plus 3 can't be 0 and x minus 3 can't be 0. So do you see how you're going to get the same thing? It can't be negative 3 or positive 3. So if that makes more sense to you, you can absolutely factor it. Uh-oh. H. Uh-oh. Why do I say uh-oh when I look at H? Well, it has a radical and it has a denominator. So remember what the two problems are. The two problems are having a radical and having a fraction. All right, so this has both. All right, so we're going to have a two-part answer. Got to deal with both parts. So what does the radical rule say? Whatever is under the radical must be greater than or equal to 0. Whatever is under the radical is greater than or equal to 0, which means x is greater than or equal to negative 5. So that's the first part of my answer. Whatever x's you're picking for your domain, they have to be numbers that are bigger than or equal to negative 5. Now, what's the second rule?
X cannot be 0.
Whatever is in the denominator
Not be 0.
cannot be 0.
x cannot be 2.
So x cannot be 2.
Why wouldn't it be plus minus 2?
Did I square root?
So that's the only time we do that? Okay.
Could
Now.
you put them on top of each other, like same
Yeah, I wouldn't put them on top of each other, maybe next to each other. It's not a fraction or anything like that. But they're two separate answers. Now, what that means is, for you, eventually when we start graphing these things, what it means is that your x's will be any number bigger than or equal to negative 5, except 2. So you start at negative 5, and you pick all the x's forever and ever bigger than that, but you have to skip over 2. You can't use 2. All the numbers bigger than or equal to negative 5, but not equal to 2. All right. Next problem. Again, guys, this is so easy. You have 2 rules. When I look at this thing, it does not have a fraction. So worry about that one, but it does have a radical. What is the rule for a radical?
2 minus x.
Whatever is underneath it has to be bigger than or equal to 0.
So x is greater than or equal to
Now, when we solve this, we have to be careful because we're going to subtract 2 from both sides. But then we're going to have to divide by a negative, and dividing by a negative switches my inequality. Don't forget all your regular rules. When you divide by a negative, you have to turn it around. So we subtracted 2, we're just getting x by itself, so we subtracted 2 and then divided by a negative. So your domain is everything less than or equal to 2. Okay? And then one more. What are my two rules for domain? Denominator cannot be 0. I don't need to worry about that because this problem doesn't have a denominator. What's the second rule? Whatever is under the radical has to be greater than or equal to 0. So whatever is under the radical has to be greater than or equal to 0. So we'll subtract 1 and divide by 3. Do I switch the sign? No. Because what did I divide by? A positive 3. I have a negative number up there, but I didn't divide by it. So I don't change the sign. I only change the sign when I'm dividing by a negative. All right, so one more time. What are the two things we have to pay attention to when we do domain? Denominator cannot be 0. So whatever, if you have a fraction, whatever's in the denominator cannot be 0. Is not equal to 0. And what's the second rule? Whatever is under the radical sign, forget about the rest of the problem, whatever is under the radical has to be greater than or equal to 0. Right? That's it for domain. Those are the two things you have to remember when you look at a problem. What if the problem doesn't have a radical and it doesn't have a denominator? Then your domain is all real numbers because then you don't have any restrictions on it.
What if you have a trinomial?
What do you mean a trinomial? Like
A trinomial under a radical?
well, then it becomes a little more complicated because the rule is still the same. So if you had one like this, then whatever is under the radical has to be positive. And that was a test question for you. You factor this, put it on the number line, and shade out.
But then how would you?
So then your answer would be written as an interval, just like it was on your test. This is exactly a test question, okay, that we just had.
Yeah.
Now, do I have anything like that in the notes?
No.
Okay,
I was just wondering.
Yeah. Yeah. Is your hand up, Leo?
I was,
Okay, so domain, denominator can't be 0, whatever's underneath the radical must be positive. Okay. All right, part 3 deals with asymptotes. Now, does anybody know what an asymptote is?
A fraction depending the points.
No, it's a good guess.
Doesn't it have to do with, when it hits the axis?
It has, it sort of, an asymptote is a line that the curve approaches but doesn't intersect. So, for example, if I drew a picture like this, this curve goes on forever and ever and ever. And as it goes, it gets closer and closer and closer to this line right here, but it never touches it. So an asymptote functions as kind of like a boundary. The curve keeps going and getting closer to it, but never intersects it. That's what an asymptote is. They can be vertical or horizontal. We got both in this picture. We're starting with vertical asymptotes, but we will do horizontals next. But they are lines that kind of define your picture. The curve gets closer to them as you go up and out and down and everywhere. Okay, so as you go off the page, you get closer to that line. It doesn't keep going down forever and ever. It gets closer and closer and closer to that. All right, so let's talk about this first problem. All my markers are running out. So y equals x plus 1 over x minus 1. Now, forget the asymptote thing for a second. If I said to you, what is the domain of that problem? What is the domain? What would you tell me? Okay? X cannot equal 1. That would be the domain. Would everybody say that? Denominator can't be 0. So x can't be 1. Here's the joyous great news. Whatever x cannot be is your vertical asymptote. So the fact that you can tell me that x cannot be 1 means we have a vertical asymptote at 1. So this is the line where x equals 1 right here. It's a vertical line where x equals 1. Here's where x is 2 and 3 and 4. So this is the line where x equals 1, and that is my vertical asymptote. That line, x equals 1, is my vertical asymptote. Why is it there? Because you told me the domain was x can't be 1, and whatever you say x cannot be, that is your vertical asymptote. So remember I told you domain is tied to graphing? We're starting it right now. You now know that you have an asymptote in your picture at 1, because that's what x cannot be. Okay, I think I'm going to stop right there. I gave that to you already, didn't I? Oh, no, I didn't. I didn't give it to you. I put it in Schoology if you want to print it.